Right, we should be good to go. We are live also on YouTube and we will be starting the lesson together. I'll record from this side. Let's begin. I'm ready. Hi, everyone. Hope everyone is okay. Welcome to the Mr. X mathematics class for functions, which is covering the grade 11, 12 functions. In this particular lesson, we will deal with the topics of the hyperbola, the parabola, the exponential, as well as the straight line function. It's going to get exciting as we're going along. It's a free class, so welcome everyone. So who's Mr. X? I am a mathematics and physical science tutor. So I teach from grade 10 all the way to grade 11, specializing mostly in online classes, but I also do some face-to-face classes. So here's how it goes. In my monthly classes, it's 250 rands for 5 lessons per subject. 250, 5 lessons per subject. So we're looking at the lessons every single day, Monday all the way to Thursday, from 7 p.m. all the way to 9 p.m. So we're doing all the topics that you'll do in grade 10, 11, and 12 for both mathematics and physical sciences. Interestingly as well, I do revision classes, and unfortunately, I've already done the Maths June revision classes, and what's left is the physical sciences revision classes, which is coming up next week. So we're looking at 5 hours each session, 250, paper 1, paper 2. So it's a total of 10 hours at 250 rands. So join that one. It's going to be fire. Well, we're teaching you all the concepts. We are revising, getting ready for the bigger stage when we go and write, and we are good to go. So yes, that's what's happening for physical science. But today we are doing mathematics. So these are the classes for Mr. X, grade 10 to grade 12, maths and physics, 250 per month, and open to everyone. Also, you can find me on socials. That is Mr. X Mathematics and Physical Sciences on YouTube and also on TikTok. And also a special mention and thank you for 1 million likes. Poo, 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 poo. I really am grateful for that, for following, for liking, for commenting, all the positive things that you guys say. Really, really appreciate. All right, having said that, the business of the day, let's do this. Are you ready? I'm thinking people are ready. So am I. First question, 2025 Northwest June, paper 1, and this question, number 5 right there. So we start on it. Write down the title. We are doing it together. Like I said initially, we've got 4 different graphs that we're going to do together. I'm looking at the hyperbola, the parabola, the exponential graph, as well as the straight line function. The question starts this way. Sketched below is the graph of g of x, which is equal to a dot b to the power x plus q. It is important when you look at a graph to be able to tell by its equation what type of function we are dealing with. So g of x is a dot b to the power x plus q. This is an exponential function. The question says the graph of g cuts the x-axis and y-axis at 1, 0 and 0, -4, respectively. And also the line y is equal to 8 looks like my asymptote, as I can see. For the first question, it says write down the value of q. Write down the value of q. Listen to this. In a typical exponential graph, the y asymptote, the dotted line, is actually the value of q. So the y asymptote, the dotted line, the line that restricts the graph, is your asymptote. So I'm looking at the line y is equal to -8 as my asymptote, which means the value of Q is also -8. So I'm learning something. The asymptote of an exponential is literally the value of Q. And for an exponential graph, we only have one asymptote, which is the Y asymptote. Q is -8. So if you are to think about it, this graph says G of X. So it's like Y is equal to. So currently it's A dot B to the power X minus 8. So it becomes the graph of Y is equal to A dot B to the power X minus 8. For 6.2, it says determine the values of A and B. Determine the values of A and B. According to what we see, Y is equal to A dot B to the power X minus 8. This is what we currently have. But on this very graph, we also have coordinates, particularly when X is 1, Y is 0. Also, when X is 0, Y is -4. So we do have those coordinates. So we're looking for A and B. Here's my suggestion. When dealing with an exponential graph, when you are substituting, start by substituting the value where X is 0. It helps you to eliminate one of the unknowns. Let me say that again. When you are substituting, looking for A, B, start by substituting the value where the X is 0. This will help you to eliminate one of the unknowns. What do you mean, say? So Y is -4, I hear you, is equal to A, I don't know you, B, and then X to the power of 0 minus 8. Notice that in maths, any number to the power of 0 is 1. So in other words, B to the power of 0 is 1. So I'm doing some math, old school. Let's go. So it becomes A times 1, which is A. Then there's -8. Then there's -4. Then you can transpose, meaning that the value of A at the end of the day is 4. So I found A as 4. That's the story. Interestingly, we need to find B. Now, judging by the shape of the graph is exponentially increasing. If you look at the exponential graph, it's exponentially increasing. It would then suggest to me that the value of B, which is holding the power, the value of B, which is holding the power, will be greater than 1. How do I know? I know because when a graph of an exponential is exponentially increasing, then it means the value of B, the base with the power, must be greater than 1. So let's confirm that. What do I currently know? I know that Y is a 4 to the power X minus 8. Now we can substitute the other coordinate, the coordinate where X is 1 and the value of Y is 0 in order to get A. So I'm thinking where there's Y, I put 0. Where there's X, I put 1, then minus 8 on the other side. We do some algebra. So a times 4 to the power 1 is like 4a transpose negative 8, that's 8, divide by 4. So eventually at the end, your b rather, it's not your a, it's your b. I think I see where the problem is. Yes, but the math is the same. So you've got your a as 4, then b to the power of x minus 8, and you're looking for b, not a, b. Thank you for that. So the y value being 0, the x value being 1 in this case, so minus 8. So eventually 4b transpose, so the value of b should be equal to 2. So as we predicted earlier, that if it's exponentially increasing, then the value of b should be equal to, or rather greater than 1. So if you're going to write your final equation of g of x is a, which is 4 multiplied by b to the power x, b is 2, minus 8, this being the equation of your exponential graph. That's 6.2. Let's try 6.3. 6.3, they are concerned about the range. Someone is asking, say, what if they don't give you values where x is 0? It's possible. You could get values where x is not 0. All you need to do is to substitute whatever value you get. Eventually, through the algebra, you will get the appropriate answers. The point to remember is that coordinates, these ones in particular, 1, 0, 0, and -4, they are existing on this graph. So they can be substituted. When x is 0, y will be -4 in this equation. When x is 1, y is 0 also in that particular equation. That's 6.2. Let's try 6.3. They are looking for the range. They are looking for the range. Now, in graphs, the range speaks to y values. So when you talk about the range, you are talking about values of y. You are concerned about y values that your graph can take. If you look at the graph, the restriction is on y is equal to -8. That's your asymptote. This means the graph cannot or does not go below -8. It doesn't exist below -8. Actually, your graph is above y values of -8. It is greater than -8. Every single y value in your graph is above, greater than -8. So the range is very much tied to the asymptote of an exponential. Knowing that the asymptote gives me an idea of the range. So I'm thinking my graph, everything above the y value -8. So all my y values are greater than -8. So I'm writing my range greater than -8. That becomes your range. You can also just say, to clarify, that y is an element of real numbers, but not forgetting the restriction, y is greater than -8. All your values of your graph are above -8. I'm ready for 6.4, step by step. The range, the domain, on the other hand, will just be strictly for the X values, your domain for the X values, just to over answer, For your domain, if you notice your graph for the domain, which is about X values, your graph is existing on the positive X-axis. Also, the graph is available on the negative X-axis. So your graph has positive X-axis, negative X-axis. Your graph or your values of X are an element of real numbers. It's available everywhere in that particular situation. Now, just to reiterate as well, because there's another way of writing this particular expression. You can say Y is an element, circular brackets, from -infinity all the way to +infinity. Notice that I did not say greater than or equal to. The reason is because the graph does not exist when Y is equal to -8. So that's why it's greater than -8. And on the interval notation, it's a circular bracket, meaning I'm excluding the value of -8 because the graph is non-existent right there on the -8 scenario. So there we are. That's 6.3. Let's try 6.4 quickly together, step by step. So people are asking for the other format. I think I've put it across to say this is how the other format is. Now, when it is included in the interval notation, then you'd put square brackets. But if it's excluded, those are your circular brackets. 6.4. Determine the equation of K. If K is obtained when G is reflected about the X-axis and then shifted 2 units to the right. It says, write your answer in the form Kx b to the power x plus p. Let's discuss. So I'm looking for the equation of K of x. K of x comes as a result of reflecting the graph of G in the x-axis. So that's the first thing that I did. I reflected the graph of G in the x-axis. Then after that, I shifted 2 units to the right. So 2 things that I did. First, you are reflecting the graph in the x-axis. Secondly, you are shifting it 2 units to the right. So we want to find the equation of K of x, which is a manipulation of G of x. And I remember what G of x is. G of x, from what we got, is 4.2 to the power x minus 8. So we need to shift him 2 units to the right. We also need to reflect about the x-axis. So let's begin. Let's start with a reflection in the x-axis. A reflection in the x-axis. Now listen to this very carefully. Every time you take a graph and reflect in the x-axis, the y value becomes negative. I want to write this down. So I'm saying if I reflect, yes, in the x-axis, what happens? The y value, it becomes negative. So literally at every particular point, when you reflect a graph in the x-axis, the y value becomes negative. Listen to this. We have g of x. That's my y, g of x. So when I reflect in the x-axis, it means that the g of x becomes negative. The y value becomes negative. I can write it as negative g of x, negative y value. G of x is my y value, negative. Reflect in the x-axis, y becomes negative. So work with me. So this becomes negative. I know g of x, 4.2 to the power x minus 8. So which means I'm now at negative 4.2 to the power x plus 8. This is the result of the first reflection in the x-axis. The y value becomes negative. All right. I'm seeing it. So y value is negative. So negative g of x, negative y value. It gives me negative 4.2 to the power x minus and minus gives me a plus. That's the first thing that I did. Secondly, we then shifted the graph 2 units to the right. 2 units to the right. So currently, we are at negative g of x. That's where we are. But I want you to understand that the moment you shift the graph 2 units to the right, you are affecting x values. X values. 2 units to the right, x values. So yes, we are at negative g of x. But when we move 2 units to the right, we write it as x minus 2. All right. Listen to this. So say uthini. Are you telling us ukuthi currently we are here? This is the result of a reflection in the x-axis. Yes, this is where we are. So are you saying when you shift a graph to the right, it's minus? Yes. Chuck Norris, yes, it's minus. G of x minus 2. So if it was to the left, it was going to be plus. To the right, it's minus. So negative g of x minus 2. Meaning, where there is x, I put x minus 2 plus 8. This is the equation of k of x, the reflection of the graph of g in the x-axis, and further on, the shifting 2 units to the right in that particular case. But we're not done, because we can even go further on this one. Listen to this. The equation says k of x b to the power x plus p. So I must have one thing that holds the power. All right, so how can we do this? Work with me. There's a minus already, yebo, but U4 can be written as 2 squared multiplied by 2 to the power x minus 2 plus 8. Okay, all right, let's bring it a bit this side. So I wrote 4 as 2 squared, which is basically minus, we have it, then the 2 squared times 2 to the power x minus 4. Mathematically, the bases are the same. So yes, I see the negative. Let me write it properly here. Mathematically, the bases are the same, so the powers must add. So this is the laws of exponents. I have a 2-hour video on YouTube talking about exponents. You can check it out. So these are the laws of exponents. Bases are the same, so the powers have to add. Old school, 2 plus x minus 2, then plus 8. Eventually, your answer is minus 2 to the power x plus 8. This becomes the final equation for k of x because they wanted it as b to the power x plus p. Just to reiterate this before we go to our next question, remember, when you're reflecting in the x-axis, y value becomes negative. The opposite is true, by the way. If you reflect in the y-axis, the x value becomes negative. So let's say we reflected in the y-axis, I would have written it like this. G of negative x, the x value becomes negative. But here, because I'm reflecting in the x-axis, is the y value that eventually becomes negative. Secondly, when you shift the graph 2 units to the right, x minus 2. If it was 2 units to the left, it was going to be x plus 2. So eventually, that's what your answer is at the end of the day, right there. All right, perfect. There we are. We are good to go. Somebody's asking, say, does the negative not affect the exponent? Let me show how it looks like. Okay, somebody may be writing, but let me show it on the side here. You see, this is as good as saying minus 1 times 4 times 2 to the power x minus 2 plus 8. Minus 1, then you can change the 4, 2 squared, then 2 to the power x minus 2 plus 8, which eventually is minus 1, then 2 to the power x, then plus 8. You can then rewrite it as you see there. So that's another way of kind of playing around with it in that particular case. So that's negative 2 to the power x plus 8 in that regard. Interestingly, just to show you something, notice that because of the reflection in the x-axis, the asymptote was negative 8. Now it's positive 8. Literally, the values of y, it was negative. So when a negative value becomes negative, or when you negate a negative, it gives you a positive. This is why your new asymptote is up there at y is positive 8. Perfect. Step by step. Let's try another one. All the graphs will be done. I see the graphs of E parabola as well as a straight line. 2016 Eastern Cape, June paper, 1, question number 4. Maybe let's try this one together and see what we can do. All right, I see your question. I think I'm answering as much as I can. So somebody's asking, said, do we always have to use laws of exponents for the final answer? Now, it depends on the context. If you notice, the question wanted us to have b to the power x. It didn't say a b to the power x. It says b to the power x. So we needed to find a way of having that b to the power x right there. I'm ready. The functions I read. The functions of f of x, which is negative x squared, negative 2x plus 3, and g of x, which is mx plus c, are drawn below. And it says with g passing through E, C, and point A. A and B are the x-intercepts, and I think they are the x-intercepts of f of x, and CD is the axis of symmetry of f. Then it says E is a y-intercept of G. E is a y-intercept of G. I'm fine with that. 4.1, we begin. Determine the coordinates of C, the turning point of F. The coordinates of C, which is the turning point of F. Listen to this. There's two ways to do this, and I must put a disclaimer. It depends on what grade you are in. In grade 12, you can do this by deriving and equating to 0, because that's what you do when you're looking for turning points, something that is learned in the topic of calculus. So you can derive, equate to 0, solve for x, substitute back to the original. Grade 12. Grade 11, what we do when looking for turning points. Here we go. So you've got the equation of f of x, which is y is equal to negative x squared minus 2x plus 3. The x value of the turning point, the x value of C, is found by saying minus b over 2a. So the x value of C, the turning point, is found by using the axis of symmetry equation. Here's what we know. The x value of the turning point is also simultaneously the equation of the axis of symmetry. I'm using the grade 11 method. You are allowed to use either. It's fine. So x is minus b over 2a. So minus, I need to, this is my a, coefficient of x squared. My b, negative 2 over 2a is negative 1. So I found the x value of the point of turning point as negative 1. So in other words, when x is equal to negative 1, it's okay to say it's the x value of the turning point, but also it's correct to say it is the equation of the axis of symmetry. Those two hold true. So I found the x value. To find the y value, you may need to substitute back into the original equation. So I want to know what is y when x is negative 1. What is y when x is negative 1? For the y value, so in essence, I find y as 4. Then I can come up with the coordinates of C. C, my turning point. You are negative 1 and 4. That becomes your value of C, negative 1 and 4. That's my story, and we are on that part. All right, perfect. I'm ready for 4.2, step by step. in that part, -1 and +4. All right, I'm ready for 4.2, step by step. 4.2, 4.2. Determine the coordinates of A and B. A and B are x-intercepts, and I want to determine the coordinates. Let's agree. Let's agree on something here. The A and the B are your x-intercepts. They must be occurring when y values are 0. Yes, the x value of A, I don't know. The x value of B, I don't know. But what I know is that these x values are available whenever the value of y is equal to 0. X-intercepts, I'm thinking factorization. 0 for y, -x², -2x plus 3. Word of advice, when dealing with a situation like this, my suggestion is get rid of the negative. In other words, avoid working with a coefficient of x² as a negative. Avoid that. So it's going to be x² divide everything by negative plus 2x, then minus 3. All this will give me 0. Then you can factorize. Options for factorization. You can use the quadratic formula, up to you, or just conventional factorization. X plus 3, x minus 1. Eventually, the value of x is -3, or the value of x is a +1. Now we need to give the appropriate AB. The value of x of A should be negative. It's on the negative x-axis. The value of x for B should be positive. It's on the positive x-axis, -3, 0. That's A. B, +1, 0. 3 marks, step by step. We are factorizing. Remember, you are free to be able to use the quadratic formula as you deem necessary, or you can just go straight to the conventional method of factorizing. Either ways, these are methods that are applicable in that case. I'm ready. I'm ready. I'm looking for 4.3. 4.3. The values of M and C. M and C belong to the graph of the straight line. So I'm looking for the values of M. I'm looking for the values of C. In other words, I'm looking for the equation of a straight line. There's an entire topic in Maths Paper 2 known as analytical geometry, the one that deals with straight lines. It's taught in grade 11. It's examined in grade 11 and in grade 12 as well. In that topic, and I have a video on YouTube for it. In that topic, we deal with straight lines. And it's important to know how to find the equation of a straight line. What do I need? What do I have to find the equation of a straight line? Hear me out, hear me good. I need a gradient. All right. I need a gradient on that line. I need at least a point on the line. Gradient and at least a point on the line. Work with me. According to the graph, I can see that the straight line passes through point A as well as through point C. So I have point A, which was given as -3, and 0, I have point C, which is given or calculated as -1 and 4. I'm looking for the equation. I'm looking for M and C. Maybe let me get the gradient. Maybe let me get the gradient. So the gradient of AC is y2, 4 minus y1 over x2, -1 minus x1 minus 3. So eventually, the gradient, you do your maths, of AC, the straight line, is 2. I found the gradient. I'm thinking now, let me find the equation on that particular case as well. All right. It means to me, I have a situation. Y is mx plus c. Mx plus c. So now to find m, I did find m as 2. I'm just left with finding c. So currently m is 2. For the y value and the x value, you can substitute any coordinate. You can choose to substitute point A, where y is -3, and the value of x, or rather y is 0, and the value of x is my -3. You can choose that. You can even use coordinate of c, you still get the same answer. Judging by the story, -6. I'm doing things old school, not skipping anything. So the value of c is equal to 6. So eventually I found my c. So my equation of this straight line is y is 2x plus 6. Yeah, bro, it's 2 marks, but it's worth it. It's worth it. Getting the right way, the right way. The more we do, like I always say, the more we do, hey, the more we know, the less we do, hey, the less we know. So we do more to know more. Somebody says, this is so helpful. I got your back. I got your back. 4.4. Here's what, boy. 4.4. Distance, length, 4.4. Pairs guap. All right, I'm ready. I'm ready. Now, I must admit that here, you can use another method, the beauty of maths. Y minus y1 is mx minus x1. This is pretty much correct as well. You will get to the same place as always. 4.4, calculate the length of CE and leave your answer in surd form. CE. C, I know you. C, you are -1 and 4. E, I don't know you. But what I know about E is that its x value is 0. Now hear me out. The point E lies on this equation, 2x plus 6. I want you to know that E is a y-intercept. And for a typical graph, a typical equation, the y-intercept is the value of C. It's the 6 here. So it's the value of C. I'm ready. Hear me out. If given an equation of a straight line, the y-intercept is the last number. The y-intercept is the value of C. So I'm thinking the value of y for E is 6. You can even calculate. You can put x as 0. You'll find y as 6. I'm looking for distance. Last I checked, the formula for distance said to me square root. Square root of what? x2 minus x1 squared plus y2 minus y1 squared. You'll find this in the topic, analytical geometry as well. Length, and they want it in third form. x2 is really up to us. So 0 as x2 minus 1 squared plus y2, 6 minus 4. The rest is calculator business, root of 5. So CE is the square root of 5 units. That's the length of CE. All right, I'm ready. Square root of 5 units. That's the length of CE. So just to reiterate this again as to how I got the value of E, remember the point E lies on this graph. E is a y-intercept. So at point E, the x value is 0. You can even calculate. So at E, who's 0, x. So I can find the y value of E as 6, which is what I did here. But very importantly, I did say, Uguti, it's easier if you think about the fact that the C value, the last value of your straight line function, is every time the y coordinate of the y-intercept. And so I found E, I found C, then I calculated the length. Sometimes they say the distance between them. All right. So I think I'm trying to make sure that it's understood. Maybe let's try the next one. I'm ready. 4.5, more interesting. 4.5, and these questions or these types of questions, whether you like it or you like it a lot, they are coming. All these ones are coming through. F of x dot g of x, you'll find them in functions. If you're in grade 12, you'll find them in functions, in cubic functions, in trig graphs. That covers grade 11 and grade 12. So you'll find them everywhere. You can't hide right there. Perfect. F of x dot g of x less than 0. I read the question. Determine the values of x for which f of x dot g of x is less than 0. Listen to this. When f of x dot g of x is less than 0 means you are dealing with a negative concept. Less than 0. Now, when two entities are multiplying, and when multiplying, they give you less than 0, it means one of them is positive and the other is negative, or this one is negative and the other is positive. Say that again, say. Break it down again. Utsini is than 0. Yebo. So I've got two entities multiplying, and when something is less than 0, it's either a plus multiplying a minus or a minus multiplying a plus. That's the condition for you to get negative. Positive multiplies negative, less than 0. Negative multiplies positive, less than 0. Sure. Siagoz. Now hear me out. It means, in essence, the graph of f of x must be positive, while simultaneously the graph of g of x is negative. Okay, the graph of f of x on the second part must be negative, while the graph of g of x is positive. All right, so plus minus, minus plus. Okay, say, what do you mean when you say the graph of f of x is positive? What do you mean that the graph of f of x is positive? It means to me the graph is above the x-axis. So whenever a graph is positive, it's above the x-axis. Let me use colors. I'm going to look for parts of the graph where f of x is positive, where f of x is above the x-axis. F of x above, I'm going to use green. I'm above, I'm above. Above, I'm above, I'm positive. I'm above, I'm above. I'm above, I'm above. Then I stop here. So the green part represents the part where f of x is positive. Okay, all right. Mina, I want g of x as negative. I want g of x as negative. Negative g of x means the graph is below. Below, 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 below. So in other words, for the first scenario, I want a circumstance where the graph of f is above, the graph of g is below. That's what I want. F above, G below. I want green and red. I want green and red. That's what I'm looking for in that scenario. Green and red. Now, looking at the graph, I don't think I can get it. There's no part of the graph where both graphs show me green and red simultaneously. I'm not seeing it. I'm not seeing above and below. I'm not. So green and red simultaneously is not existent. So this situation is not existent. It's not there. Okay, say. So green and red can't work. No, we can't. All right, let's try the other one. What do I want? I want f of x as negative this time. So f of x, where are you as negative? Here, below the x-axis. Also this portion below the x-axis, it's negative here. And I want g of x above. Above and above. I'm above and above. There, g of x going above, 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 above. Now think with me. Think with me. The graph of g continues. And as it continues, it's above and above, above and above. What am I looking for? I'm looking for green, red simultaneously. I found it. I found it. Where? Say. Check this out. If you were to draw a line right here at point B, notice that after the x value of B, after the x value of B, the graph of g of x is above, the graph of f of x is below. After the x value of g, of B rather, the graph of G is above, still green, it continues all the way, while F is below. So the green and red part simultaneously occurs English on all x values greater than 1, x values bigger than 1, x values after 1. I will say, where did you get the 1 from? I found out that B was 1 and 0. That's what I found. B, it was 1 and 0. So in essence, it looks like to me that the moment when the value of B is, or rather the value of X is greater than 1, then graph of G would be going above its positive, above the x-axis, while the graph of F is below the x-axis right there. So in essence, every time, just to reiterate this quickly, every single time you get two entities less than 0, it means one should be positive, one negative, the other negative, then one positive. Whenever a graph is positive, f of x is positive, the graph is above the x-axis, its y values are positive. F of x is positive, above the x-axis. When it's below the x-axis, it's negative. The first scenario could not work. We couldn't find above f of x, below g of x. We couldn't. But for the second one, we can find a below f of x and an above g of x. And in that case, it strictly happens on all x values which are greater than 1. And the question had said, determine the values of x for which f of x dot g of x is less than 0. All right, that's the story, and I'm sticking to it. I'm thinking that we should be okay. One of the best things to do would be, if you can, if you can always draw using colors, right? So you can determine, up and below, up and below, and so forth. That's what will help you to actually get what you need. This section that I just taught, I actually have it again on YouTube because I have another topic, or another functions topic that I did, and I was doing only past exam papers. And towards the end of that video, I taught this. Like, I think I taught it for like 20 minutes or so, and I had so many different examples to help us to understand. Something to check as well. Let's go. I'm thinking hyperbola is in the house. Hyperbola is in the house. 2022 Senior Certificate Paper 1 right there. Let's go for it in that case. 2022 Senior Certificate. I'm ready. There's an entire story that follows here. Consider the graph of g of x. G of x being a over x plus p plus q. The following information of g is given. The domain is x is an element of real numbers, but the value of x cannot be -2. The x and y intercepts are at 1, 0, x-intercept, ukelo, at 0, -½ y-intercept. So this is the information that has been given by the equation, or rather by the question. For 6 marks, 5.1. Show that the equation of g is given by g of x is -3 over x plus 2 plus 1. That's what I'm looking at. Okay, sharp. Hear me out. The hyperbola. The domain will give us an idea of where to start. Whatever happens, the value of x is an element of real numbers, but x can never be equal to my negative 2. So when I punch it in eventually, in this particular case, I'll write y is a over x. I'll still write p plus q. This should give me a bit of a hint. Also, because I've got an x-intercept at 1, 0, and a y-intercept at 0 and negative half, I'm thinking we may end up having to substitute, and from it, we can try and find our particular simultaneous equation. I want us to think together, we'll say, okay, what is going on in this particular case on that part. So listen to this very, very carefully. So we have an idea of the domain. The domain being the value of x as an element of real numbers, but x not being equal to negative 2. So here's how you're going to put it in the particular question. So you're going to say y is equal to a over, now it's a plus p, and then here there's a minus 2. So when you write it, you say x plus 2 plus q. I will say, yebo, I'm there, I'm on this part there, on this part. It says to me, y is equal to a over x plus 2 plus q. But say, why are you saying plus? Well, now they said the x cannot be equal to negative 2, because this x cannot be equal to negative 2 is an indication of the asymptote of the x part of your hyperbola. Yebo, it's negative 2. But when you put it in an equation of plus p, it's going to be plus 2. So the minus 2, then the plus 2. So that's the first thing that is taking place. So where there's p, then it's a plus 2. So that's the first thing. But now I found the p part. I don't know a, I don't know q. Maybe let's substitute. We'll substitute the y, the x-intercept first, which occurs when y is 0, and the value of x is 1. So I go 1 plus 2, then plus q. So which means I've got a over 3, that's my 0, plus q. You have an option here. You can cross multiply everything by 3. So this gives me 0, cross multiply a over 3 by 3. It gives me a, cross multiply q by 3. It gives me 3q. So eventually I have my first equation. The first equation arising because it's literally substituting the value of x as 1, 0. So I get equation 1. Equation 2 would come as a result of substituting the y value, the y-intercept. So here's where we go. So this time I'm going to say sub x is 0, y is negative half. Let's go. So it looks like to me, I've got y is negative half. I'm here. And the value of x is 0, then plus q. I'm trying to come up with my second equation so that I can solve it simultaneously. So this becomes a over 2 plus q is negative a half. Again, you would be correct to cross multiply everything by 2. Everything by to get rid of the 2. So negative half times 2 is negative 1. A over 2 times 2 is a. And then 2 times q is 2q. You have the liberty to make a the subject of the formula, which you can do if you want. Actually, I can even do it all the way from equation number 1. I can rewrite equation number 1 and say minus 3q is equal to a. Maybe let me call this equation 1 and this equation 2. Then after this, I will substitute equation 1 into equation 2. Now, before I do that, let me reiterate. What gave me a good idea? What gave me a good idea was the fact that they told me the domain. X is an element of real numbers, but X is not equal to negative 2, which basically is your asymptote. And so when I put it into the equation, the minus, we write it as a plus 2. Then I substituted the X and Y intercepts, and from them, I was able to form equations. So look at it. I said when X is, or rather when Y is 0, X is 1, 1 plus 2 or 3 law. Then I multiplied this by 3, 0 by 3 is 0. A over 3 by 3 is A. Q by 3 is 3Q. Then I did make just now A the subject of the formula by transposing. Same thing I did on the other side, because this time I'm dealing with EY intercept. From it, I was able to say when X is 0, Y is negative half. So where there's X, I put 0. Where there's Y, negative half. Algebra, I cross multiply. Negative half times 2, negative 1. A over 2 times 2, A. 2 times Q, 2Q, equation 2. Then it means sub equation 1 into equation 2. 1 into 2. So it's negative 1 is equal to A negative 3Q plus 2Q. Negative 1 is equal to negative Q. Divide by negative. The value of Q is 1. So I found the value of Q is equal to 1. I can find UP, or rather UA, because now I already know what Q is. So I can just quickly substitute into equation 1, where I said to myself, A is negative 3, UQ is 1, so the value of A is negative 3. True to what they wanted, A, negative 3. Q, positive 1. We found them. Then the plus 2, as can be seen right there. So this becomes your answer with about 6 marks in that particular part. So that becomes your answer right there. So remember, if the domain is -2, when you substitute it back into the equation, is plus. X is not equal to -2. Put it as a plus 2. That's 5.1. Let's try 5.2 together a bit. So just to reiterate, the domain of a hyperbola X is -2. When you put it back into the equation, it's a +2, as can be seen here. Then I simple substituted after that the X and Y intercept. I made a simultaneous equation. Then from there on, I am able to find A, Q, and ultimately the equation of G of X. 5.2, they want range. Now, as of consequence, listen to me. As of consequence, when it comes to a hyperbola, the X and Y intercept, the X and Y asymptotes are really the tellers. They are the tellers of the domain and the range. Particularly, the X asymptote tells me about the particular domain. All the time, X is an element of real numbers, but X can never be equal to -2. That's for the domain. The range on the other side is told by Q. So the range is told by the Y asymptote, which is the value of Q. And typically, the Y asymptote here is Y is 1, but that's not what I'm looking for. That is not what I'm looking for. I'm looking for the range, but I'm giving the idea that for the range, it's strictly very much so connected to the Y asymptote. And we always write Y is an element of real numbers. But whatever happens, Y can never, ever be 1. And there's many ways to write this, by the way. But basically, Y is an element of real numbers, and the value of Y cannot be 1. 5.3, I'm ready. 0.3, I'm ready. I'm ready. I'm ready. Here we go. The more we do, hey, the more we know. The less we do, the less we know. We do more, we will know more. All right, let's try another one. 5.3, something's happening. 5.3, something is going on. The more we do, the more we know. 5.3, something big is happening on 5.3. 5.3 says the following. And I want to run with it on this one right there. Question 5.3. It says determine the equation of H. Whose H? H is the axis of symmetry of G in the form Y is mx plus c, where the value of m is greater than 0. So I need to hear the story. I'm determining the equation of an axis of symmetry of a hyperbola. Let's learn a bit. I want you to understand that there are two axes of symmetry for a hyperbola. There's what is called the positive axis of symmetry for a hyperbola. The format is Y is X plus C. Say that again. Say, are you saying ukuthi hyperbola there's a positive axis of symmetry. Yebo. How is it written? Y is x plus c. Notice that the gradient or the coefficient of x is 1. It's positive. In other words, here, m, the gradient, is greater than 0, is positive. Now, it's important to understand, and there's many ways to do this. When looking for the x symmetry for a hyperbola, the format y is x plus c. This y value and this x value, these values that you see, they are your x and y asymptotes. Okay, say, Utini. You're saying to us, if I'm looking for the equation of the axis of symmetry for a hyperbola, and it's a positive axis of symmetry, in some questions they say increasing axis of symmetry. It's a positive increasing axis of symmetry. If I'm looking for it, are you telling me Uguti, the y and the x are the asymptotes? Yeah, bo. This one is a positive axis of symmetry, or you can say increasing axis of symmetry. All right, I'm ready. Positive, increasing, I'm ready. How about when it's negative, say? How is it written? Negative x plus c, the gradient is less than 0. It's a negative axis of symmetry, a decreasing function. Question says to us, we're looking for the equation of the axis of symmetry where m, the gradient, is greater than 0 when we are positive. We are looking for that equation. Y is x plus c. I'm going to use this one. M is greater than 0. The coefficient of x is a positive 1. It's a positive increasing axis of symmetry. Whose y? Whose x? Y is the y asymptote. Uangelo. X is the x asymptote. And yebo. It's negative 2. Yeah. That's why they said x is not equal to negative 2, the asymptote. The value of c I can get by transposing c is 3. Therefore, the value of y becomes x plus 3. So this becomes the equation of h, which is the positive axis of symmetry. So h of x is x plus 3. That's your answer, as you can see it. Positive axis of symmetry. There's many ways to do it. I must say that. There's many ways. Somebody says, don't we need to calculate the gradients of the hyperbola and all? Not necessarily. Actually, by doing that, you are in line with what you just said. My suggestion, and there's many ways, keep saying there's many ways, because there is, y is mx plus c, and I know, Uti, if I'm looking for the positive axis of symmetry for a hyperbola, y is x plus c. Then if I'm looking for the negative, y is negative x plus c. And I did find my c and collected my equation just as it should be. I'm ready for 5.4. I'm ready because the more we do, the more we know. Because the less we do, the less we know. We do more, we will know more. Now 5.4, Yolande. Now 5.4. What do they want? Write down what? The coordinates of K1. K1. Who's K1? K1 is the image of K. Who's K? K is 1, 0. K1 is the image of K reflected over H. I'm looking for K1, the image of K reflected over H. Now, last I checked, H was Y is X plus 3. I'm looking for the reflection of the coordinate OK where in the line Y is X plus 3, which is H calculated from 5.3. I need to think here a bit. I need to think a bit on this one. Listen to me, nothing hectic. It's pretty much straightforward. Follow this lead. So here's what you're going to do. Y is X plus 3. What do you want? I want K image. So this is what you do. You take the K X value, put it into the equation, then get the new Y. I will say, Utini, yebo. Take the K X value, put it into the equation, because what it means when you're reflecting, it means I am subservient to the axis of symmetry. Y is X plus 3. So whatever I'm reflecting my K value to be, it must be according to Y is X plus 3. So substitute the value of X as 1 and the reflected value of Y would be 4. All right. So K1 is 4. Yeah. K1 is 4. All right. So say you substituted X as 1 here. Yes. So that you can find the reflected Y value or the reflected value of Y in that case. Yes. So by substituting the value of X as 1, I get the value of Y. Okay, so how do I get the value of X reflected? Substitute the value of Y original. Say that again, say that again. To find the value of Y reflected, substitute the value of X in this equation. I've substituted X as 1. I got Y as 4. Then for the next one, I want to find X. So this time I'm going to substitute Y as 0 so that I can find X. When I do my math, X is -3, and this becomes the reflected value of K, where you are saying -3, 4. It's a matter of, it's like saying this. Let me show you. Oh, it's going to get interesting. All right. So look at it. Aniti, the reflecting guy is Y is X plus 3. And it's so in the new guy, the Y value is X plus 3. In the new guy, the X value is Y minus 3. That's basically what happens. So you take the original, you are given the Y value. It's X plus 3, where X is 1, then I get Y as 4. Then the other one for X, I transpose, it's Y minus 3. So the X value is Y minus 3, where Y is 0, 0 minus 3 gives you -3. So this is another way to look at it. So you are reflecting a coordinate K in the axis of symmetry. Just substitute the X value in the axis of symmetry, you get the Y value. Substitute the Y value in the axis of symmetry, you get the X value. And that ultimately becomes your answer in that particular case. So all you do again, just to reiterate, remember from 5.3, I need from 5.3, from 5.3, I'm going back quickly. From 5.3, we found the axis of symmetry as x plus 3. The coordinate of k, which is 1, 0, and we're given k, Naila. This k is reflected in this line. And we just want to find the coordinates of k. I'm giving the idea that substitute the x value of the original in the reflection line, you'll get the y value. So y is 4. Now y. Then substitute the y value of the original, you get the x value. Y value original, 0 gelo, and I can get the x value. Then you transpose. -3 is x. So the value of x is -3. So k1, k prime rather, is 3, -3 and +4. All right. You can't leave the lesson without trying something. No, you can't. You gotta try something. No, you can't. You gotta try something on that one right there. Let me give you something to try, something small but good, because apparently the more we do, the more we know, because the less we do, hey, the less we know. Let's do more to know more. Here's a question. I'll give you 3 minutes. Okay, 4 minutes on this one. 2014 exemplar paper 1, question 4.2. 4 minutes. Try it, Chuck Norris. Chuck Norris. Try. Chuck Norris. Try. Pesguabo boy. 4 minutes. One more minute. All right, I think I've given you way more than enough time, more than what I had said, but let's see together how this works. So the graph of an increasing, and that's key, the graph of an increasing exponential function with the equation f of x is equal to a dot b to the power x plus q has the following properties. So I'm looking at the range as y greater than -3. And then the points 0, -2, 1, and -1, they lie on the graph of f. For 4 marks, determine the equation that defines f. Now listen to this. Here's my story. The first thing that we should note is that there is a range. When I did the first question on exponential graphs, I gave the idea that the range is intimately tied to the value of q. So if my range is y greater than -3, it means my asymptote q is -3. So maybe that's the first thing. I need to write a dot b to the power x minus 3. So the value of y, the y asymptote q, should be -3. That's the first thing I see. Points 0, -2, yebo. Points 1 and -1 lie on the graph. I gave a disclaimer also in the first question, Ngati, when you are substituting in a typical exponential, start by substituting the value of x as 0. It eliminates one of the unknowns. So in other words, I'm going to sub x as 0, y as -2. So here we go. A dot b, who x wami is 0, and the y is -2. then minus 3 from here. All right, I hear you, I see that. And then what? So I'm thinking a, b to the power of 0 is 1. So any number to the power of 0 is 1. So it's a times 1. There you are. I'm thinking a times 1 is a. Transpose minus 2 plus 3. The value of a is 1. I'm winning. A is 1. All right. Let's go. A is 1. So currently, you have a as 1, b unknown to the power x minus 3. That's my story currently. Now, this can also be written as just b to the power x minus 3. I mean, 1 times anything does not really change it. So remember, I had to be careful about who I substitute first. I needed to substitute where x is 0 for the purposes of eliminating the unknown. All right, so remember that. The next one says 1 and negative 1. So the value of x is 1, y is negative 1. So I'm looking for the value of b, x is 1, and I'm looking for the value of b. So you do the maths, b to the power 1 is just b, negative 1 plus 3 is 2. So the value of b is 2. And true to what they wanted, it's an increasing exponential function. It's an increasing exponential function. So here we go. It's definitely an increasing exponential function. So the value of b has to be greater than 1. So ultimately, when you're writing your equation, it's y is a, which is 1, b, which is 2, to the power of x minus 3. And that's where the story goes. Or better still, 2 to the power x minus 3. This is UF of x, 4.21. Did you get it or did you not? Did you or did you not? Bathini bona. Did you or did you not? Hey, I did. All right. Almost sounds good while learning. People are saying, you know what? I'm getting there, somewhere there. I'm winning. I see my mistakes. I'm learning. And that's a great thing that you're doing. 4.22. 4.22. I'm ready for 4.22. I know also on YouTube Live, you guys are also saying the same thing. I've got your back. I got your back. 4.22. I'm ready. Let's take this out. 4.22 says the following. Describe the transformation from f of x to h of x. Describe the transformation from f of x to h of x. All right, let me hear this out. There's 2 ways to think about it. For starters, f of x is 2 to the power x minus 3. H of x on the other side is 2.2 to the power x plus 1. We need to describe how we moved from here and ended up there. What transformations did we do to ensure we move from f of x to h of x? Let's think. I can manipulate h of x because here the power of x is 1. So I can say the bases are the same, so the powers, they add. So it becomes x plus 1, then minus, or rather plus 1 as well there. Say that again, say. Well, what did you do? What did you do? Well, the power of x is 1. Since the bases are the same, the powers, they must add. 1 plus x is like x plus 1. Then there's a plus 1 as well. This is another way of writing h of x. Okay, siyakuzwa. Another way of writing h of x. Okay, sharp. But say our f of x is 2 to the power x minus 3. Your h of x is now 2 to the power x plus 1 plus 1. Let's start with the x plus 1. There was x. Now there's x plus 1. There was x. Now there's x plus 1. Okay, so what does that mean? What did we do? It looks like to me I must have done this. F of x plus 1. Think about it. Originally, there was x in f of x. In h of x, there's now x plus 1. So this type of transformation where there was x, there's now x plus 1. This type of transformation literally is a translation or a movement 1 unit to the left. Yebo, lapo. So we shifted 1 unit plus 1 to the left. So this is why we can conclude properly that where there was x, there's now x plus 1, which is a shifting 1 unit to the left. So I'm okay with that. I'm okay with that. Okay, sharp says Yaguz. So 1 unit to the left. Now minus 3 la. We have minus 3 here. So then there is a plus 1. Originally, we have minus 3. Hey, new guy, plus 1. Minus 3, okay, plus 1. What did we do? Listen to this. So the minus 3 on the outside looks like I must translate. Originally, I made minus 3, and this would be your y asymptote. Literally, this minus 3 as given here is your y asymptote. Suddenly, you have a new asymptote. Your y asymptote was here. Y is negative 3. But from here, your y asymptote is at y is positive 1. What did I do to move my asymptote from negative 3 until I get to a positive 1? Let me see what I did. I must have said, okay, it's f of x plus 1, I know. But what else did I do? Plus 4, which means I shifted, or rather translated 4 units up. I will say, Kanjani, bro, Kanjani, look at it. And if you say plus 4, minus 3 plus 4 is plus 1. So you are describing what happened. So I shifted 1 unit to the left and translated 4 units upwards. That's exactly what I did in this particular scenario. And that becomes your answer in essence. Shifted 1 unit to the left, yebo, then translated 4 units upwards. All right. That becomes, did you or did you not? Did you or did you not? Come on now. I want to hear. So to translate, go up. So literally, if you were to write it in a notation form, it will be f of x plus 1 plus 4. So the f of x plus 1 in a bracket, signifying that I shifted 1 unit to the right. That's why I end up with the plus 1. Then the minus 3 shifted to a plus 1 from an asymptote of y is negative 3 to an asymptote of y is positive 1. I must have gone up by 4 units. So it's literally you're describing, so you write it down. I was just showing you here, but you shifted 1 unit to the left, okay, and then what? You translated 4 units up. So that becomes your story in that particular instance. Because the more we do, the more we know. Let's check another one. Let's try another one quickly together as a team. Obviously, our time is moving, but we'll try another one, okay? Just to reiterate all these things. So you write it in words. I just put down quite what you need to do, but you can write it in words. I'm ready. It's gone. It's going. 2023, November, paper 1, and it's question 5.1 all the way to 5.6. I'll do this one with you, not for you, with you. So me and you together as a team and as a family right there. 2023 November paper 1, question 5.1 all the way to 5.6. Here we go. The graph of f of x is equal to negative a half x minus 1 squared plus 8. And the graph of g of x, which is d over x. Now, I did say that merely at looking at an equation, you must be able to tell what function it represents. F of x is a parabola and is written in the turning point format, in the format of a x plus p squared plus q. So this is the turning point format. That's f of x. G of x, quite interesting. G of x is d over x. This looks like to me like a hyperbola. I will say, yeah, bo, it is a hyperbola. And if you notice something, it's a hyperbola where the x and y axes are your asymptote. So literally, a plus 0 plus 0. The x asymptote, y asymptote, they are both equal to 0, which translates to the y and x axes. Say that again, say that again. Utini. You are saying to me, say, it's d over x, and it looks like it's a typical graph of a hyperbola restricted strictly on values of y is equal to 0, x is equal to 0, which typically are your x and y axes. Just by looking, you can tell. Danko siyabonga. 5.1, here we go. 5.1 says, write down the coordinates of the turning points of UF, which, by the way, is point B. So I need the turning points of F, which is point B. Well, because I've got the turning point format, I can quickly go and pick it up. And from it, I can say X is 1, Y is 8. So the point B is 1 and 8. That's B for you. The turning point format, point B is 1 and 8. Because the more we do, the more we know. The less we do, the less we know. So B is 1 and 8. So you're picking it up straight up from the turning point format, 1 and 8. It makes sense as well, because I look at it, the X value of B is 1, and the Y value of, or rather, the X value of B is positive, and the Y value of B is also positive. So it's 1 and 8. All right. I'm ready. I'm ready for this one. Calculate, I'm on 5.2. Calculate the value of C, or the coordinates of C. Calculate. The point C is a y-intercept of the graph of F. So at point C, we are talking about the y-intercept. So at this particular point is the y-intercept. So which means the X value should be 0, or the X value should be 0, and we don't know the Y value. So I want to find Y when X is, or when X is 0. So I'll substitute here. I'm looking for Y. Calculator is our friend. What's the value of X? X was 0. It's the y-intercept. The rest is algebra and maths. Confirm. I've confirmed. I'm thinking the value of Y is 15/2, or you can say 7.5, but 15/2 sounds good to me. So that becomes your answer, 0, 15/2. 5.2, step by step. I'm ready for 5.3. I'm ready for 5.3. Here we go. 5.3 says, calculate the value of D. Calculate the value of D. Now, as we know, we are given g of x, which is y, is equal to d over x. Now, I don't know what d is. I really don't know. But judging by the hyperbola, the graphs of the hyperbola are drawn in the first quadrant and in the third quadrant. That's where the hyperbola is, first and third. So which means D should be positive. They told me that OB, the turning point, is a point of intersection of F and G, suggesting that the point B is available on this graph. In other words, my B is 1 and 8. When X is 1, Y is 8. That will help me to find OD. Cross multiply. The value of D is 8. Because OB, that point is available on your literal point, which is B, point of intersection. I'm ready. I'm ready. I'm ready. Let's keep going. I'm ready for that one. I'm ready for that one. I'm ready for that one. Let's try another one. They want the range of G. The range of G. the range of G. Follow my lead. I got your back. The range of G. Quickly on that one. Someone is writing, but quickly. So remember, the equation of G of X is D over X. And Mina, I said the only coordinate that I know that is on G of X is the coordinate when X is 1 and Y is 8. Shuti, where there is X as 1, I put Y as 8 and I found D as equal to 8. I just cross multiply. The range of G. Talk to me. So G of X is the equation 8 over X. I did say earlier that the Y asymptotes and the X asymptotes are the Y and X axes. So in other words, the Y asymptote would be Y is 0. So the range of my graph is Y is an element of real numbers, but whatever happens, Y cannot be equal to 0. That's literally how you write a typical graph or a range of a hyperbola. Range and domain of a hyperbola. It's always X an element of real numbers, Y is an element of real numbers, but all the time it cannot be equal to 0. All right, cannot be equal to 0. But all right, in this case, here's grab on 5.5. Here we go. For which values of X will f of X dot G of X be less than or equal to 0? F of X dot G of X be less than or equal to 0. Now, earlier on, I did allude, Uguti, if it's less than or equal to 0, then we're looking at positive, negative, or negative, positive. That's less than or equal to 0. Positive, negative, negative, positive. Just in case it comes out a bit differently, listen to this. If it was greater than or equal to 0, then it's positive. So I'm going to have positive, positive, or negative, negative. Literally, in that case, if it was greater than or equal to 0. So just in case it comes out, please do remember in that context. Sure, it's grand lab. Plus, plus, minus, minus. Thank you. But in our case, it's plus, minus, minus, plus. So plus of f of x, positive f of x, is above the x-axis. So let me work on it. Above and above, above and above, above and above, above and above. So that's positive f of x. For positive g of x, or rather for negative g of x, we're looking at this part of the graph. This is my negative g of x. So the pink part is negative g of x, while the typical red part is the positive g of x. So what am I looking for? I'm looking for part of the graph where f is positive, but g is negative. So let me see where that happens. So red, pink, that's what I'm looking for. Red, pink. I'm thinking anywhere from here up to here, I have red, pink. Yebo. Because this portion from there to there, red is positive above the x-axis. But from here, it's negative below the x-axis. So positive, negative, pink, red is between -3 and 0. I will say that again. Yebo. It's red, pink, way between -3 and 0. So between -3 and 0, the graph of f is above the x-axis. But between -3 and 0, the graph of g is below. But there's a disclaimer. There's a disclaimer. So say in English, you are saying between -3 and 0. Yebo. That's what I'm saying. What about in maths? I'm saying -3 is less than or equal to x, but x is less than 0. Aibo. Why are you saying less than 0 for x? Well, I hear you say it less than or equal to. Then Lana, what's going on now? Why are you saying less than? It's because I need to respect the idea that the graph of g is non-existent on the y-axis. It's an asymptote. So it cannot be less than or equal to 0. It can't. The graph of g does not even touch the asymptote of y-axis, which is x is 0. So the restriction must exclude the asymptote. So -3 less than or equal to x, but x cannot be 0. Another way to write it is to say x is an element square bracket from -3 to 0 circular bracket. That's the first thing I see there. Asymptote must be respected. So that is when I had plus minus. All right. Let's see the other way around. Let's see the other way around. The other way around. Let's see the other way around. I'm ready. Check this out. I need minus and plus. So who's negative? I want F negative, please. Below. I want G positive. G is positive everywhere here. So I need green and red. I need green and red. I'm thinking green and red starts anywhere after 5. Yebo. Anywhere after 5. So when the graph of G is above and the graph of F is below, that happens when X is greater than or equal to 5. X greater than or equal to 5. If you want, X is an element 5 all the way to positive infinity. These are your answers to that story as is right there. X greater than or equal to 5. G is above, F is below, G is positive, F is negative. Let's go out with a bang. I'm ready for 5.6. Last man standing. We are going out with a bang. Because the more we do, the more we know. Because siyafunda futhi sifunda mahala. Hawu, asibonge Mr. X. 5.6. Pezwa. 5.6. There's a story, and I'm going for it. 5.6 says to me, calculate the values of K. The values of K so that h of x, which is -2x plus k, will not intersect the graph of G. Okay, all right. I need to hear this out. What you're saying, say, calculate the values of K. I don't even know what K is. But what I know is that OH of x and OG of x will not intersect. Now, let me do some logic. Listen to me very carefully. Now, this combines issues to do with nature of roots, the discriminant, and so forth. At any particular point, if two graphs, listen to this, if two graphs are to intersect, then it means they are discriminant, which is b squared minus 4ac. Their discriminant must be equal to 0. So if we intersect, then our discriminant, b squared minus 4ac, must be equal to 0. So when you do your equations, bring them all together, identify B, A, and C, that discriminant under intersection, it must be equal to 0. All right? All right? All right. Okay, so what if they will not intersect? Not intersect. Then it means b squared minus 4ac is going to be less than 0. In other words, there are no roots. They don't meet. There's no particular part when you can have an x and a y that is available on both graphs. They do not meet. All right. Okay, maybe let me find the discriminant. Okay, so I have h of x. I have g of x. All right, I'm just looking for the discriminant, and then after that, I will then conclude, because they don't intersect, I'll find the value of k. Negative 2x plus k, g of x ngiyamazi, 8 over x. I do some algebra here. Maybe cross multiply everything by x. Negative 2x squared plus ukx. All this is equal to 8. Then maybe bring them home. I've got negative 2x squared plus ukx minus 8 is equal to 0. From here, I can identify my A, coefficient of x squared, my B, coefficient of x, my C, negative 8. I can get my discriminant. I can. So the discriminant will be b squared. B is k. K squared minus 4 times UA, negative 2, times UC, negative 8. So my discriminant is k squared minus 64. All right? So that's the discriminant. And I did say the rules and the laws and the maths support the idea that if perchance the graphs intersect, then that discriminant is equal to 0. But if they don't intersect, the discriminant is less than 0. The roots are non-real. K squared, they will not intersect. Minus 64, less than 0. Difference of 2 squares, k minus 8, then k plus 8, less than 0. This is now inequalities, and eventually your typical critical values is going to be k is 8 or k is negative 8. But we want it as less than 0. So graphically speaking, your answer is negative 8 is less than k is less than 8. I will say What you mean, man? What you mean? There's a topic of inequalities on my YouTube channel as well. And when I taught it, if you're solving an inequality, k squared minus k, the coefficient of k squared is positive. It's a smiling graph. Your particular story, critical values is -8 and 8. You want something less than 0, yebo. You want something below the x-axis. Below the x-axis is between -8 and 8. So that's why your k value is between -8 and 8. The more we do, the more we know. Because the less we do, hey, Kosiam, the less we know. Thank you so much. This has been Mr. X, the free class that I've given unto you. Listen up, there's more that I offer. I did say to you initially, I did say that I offer online classes. Imagine if I'm doing this and it's free. Hey, imagine when you are paying and it's very affordable. Say, how much? Maths and physics, grade 10 to grade 12. I am doing that at 250 rands per subject, 5 lessons a month. Math and physics. And we've been on it since February and we are on fire, literally. So you can join those classes, and I did put them across. The dates are given there, grade 10, 11, and 12, and the times are from 7 p.m. to 9 p.m. from Monday to Thursday. And I did say also as well, I am doing physical science revision sometime on the Wednesday, the 10th of June, and Monday, the 15th of June. It's going to get crazy. Paper 1 and paper 2, 10 hours. 10 hours. 5 hours paper 1, 5 hours paper 2, and that amount is 250 rands. This has been me, Mr. X, available also on YouTube and TikTok. And again, thank you so much for 1 million likes. You guys are amazing. Thank you. I appreciate every single thing that you did. Thank you to the YouTube channel family, which was listening the whole time. Thank you. Really appreciate. I'm stopping the lesson. And then after this, there are people that are asking, Uhuti, so say, how do we get into your groups? You know, and thank you so much for the thank you messages. Really appreciate them. You guys are very welcome in Africa. We are always grateful for every single thing that people do, because there's nothing for free, apparently. My number is 073 974 8498. 073 974 8498. So if you want to join my groups, my WhatsApp groups, and there's lots of them, I send documents, I send videos, I send notes, I send encouragement. The guys in those groups are active. They help each other with schoolwork for both grade 11s and grade 12s and grade 10s as well. Tell your young sisters, your young brothers, your cousins, your friends, your neighbors, your haters that there is help. And I always tell my students, I can save you because I can. Thank you for joining the lesson. All right, I want to stop the recording now. And then to the YouTube family, thank you as well. I want to stop the live stream. God